Hi, everyone. Welcome back to another edition of Talking About Technology or Stories About Technology with me, Jasprit Pindra, who also wrote the book. I also wrote the book Tech Whisperer, and that's what you see here. Off late, people have been telling me that my articles or speeches or conversations have been quite pessimistic, quite dystopian. And I'm kind of perhaps looking at sometimes a darker side of some of these new exciting digital technologies like artificial intelligence, blockchain, cloud, even the humble computer. And I'm kind of wondering about how these are rapidly depleting our natural resources, contributing heavily to global warming, climate change. Now, obviously, some of my recent thoughts have been disappointing my largely technophile audience, given the prevailing narrative that these technologies are clean and are actually supposed to save the planet, not destroy it. Therefore, the question that often gets thrown back at me is there a technology or a set of technologies that can actually save the world rather than destroying it? And in this particular talk, I'm going to stick my neck out and say that there is one, and it's called nuclear fusion. Now, I'm not alone in thinking this way. People far, far greater than me, Stephen Hawking, for example, felt the same. And he said shortly before he died that I would like nuclear fusion to become a practical power source. It would provide an inexhaustible supply of energy without pollution or global warming. Nuclear fusion is not a new concept. Scientists have known about it since Einsteinian times, and it is the phenomenon that powers our sun. Anjana Ahuja, a Financial Times writer, uh, reporter, actually wrote very evocatively in it recently, and she said, the fireball at the heart of our solar system, which is the sun, is powered by nuclear fusion. The crushing pressures in the sun's core squeeze hydrogen nuclei together so powerfully that they overcome their natural repulsion and they fuse. These nuclear clinches generate large particles with masses that are not quite the sum of their parts. The missing mass becomes energy, a fiery embodiment of Einstein's most famous equation E equals mc square. The equation shows that in terms of energy production, a tiny, tiny bit of mass, m, goes a long way thanks to the colossal multiplier of c, which is the speed of light, which is equal to 300,000 kilometers per second squared. Fusion is not the same as fission, by the way. And in fission, the nucleus of an atom splits into two or more smaller nuclei, realizing or releasing the vast amounts of energy holding them together and powering nuclear reactors and, unfortunately, thermonuclear bombs. Fusion, on the other hand, uses widely available chemicals you might have heard of, like deuterium and tritium, and theoretically extracts an energy equivalent of 1 million gallons of oil from one glass of these chemicals. Now, if we could harness it, this could produce 9 million kilowatt hours of electricity, which could, for instance, power your house for the next 800 years. One glass. No wonder, therefore, that physicists have been attempting to play God and to try a fusion reaction for the last many decades. Fusion is probably the greatest technical challenge humanity has ever taken on, writes Arthur Turrell, author of The Star Builders, which is actually a book on all those fusion experiments and all the scientists who have worked on fusion. The first successful experiment was actually in the 1950s, so almost 70 years back, when Soviet physicists built the first fusion prototype using a method called magnetic confinement fusion. Now, this apparatus, the box, was called the tokamak. And tokamak is actually a Russian short form for toroidal chamber with magnetic coils. And this tokamak has become the model for most further fusion experiments. Now, basically, this trapped deuterium and tritium plasma is is put in place by super powerful magnets, and their nuclei are fused by heating them to high temperatures hotter than the sun. And this happens in the tokamak. This experiment that time created helium and vast amount of energies and actually became the first nuclear fusion in a lab. Now, before you kind of get all excited saying that fusion has happened so far back, there's a big problem. And the problem is that the energy required to make this happen was far more than the energy released, thus defeating the purpose, making the process hot fusion and not really nuclear fusion. Now, this disappointing result has consistently repeated itself since no one has been able to generate more energy than the system consumes. And this planet saving technology remains a gleam in every nuclear physicist's eye. As it happens with most of these technologies, this one has also been muddied by multiple nuclear fusion discovery scams. Juan Perón, the husband of famous Eva Perón, who sang Evita. So Juan Perón, Argentina's president, claimed in 1951 that his scientists had cracked nuclear fusion. In fact, he said that fusion fuel will be available like milk in half-liter bottles. It wasn't. Two Utah University chemists created a lot of excitement, and they claim to have done something similar in 1989. But both these claims inevitably were proven to be hoaxes, sending the promise of this technology back to science fiction and Einstein's equation. However, there is hope. A few recent experiments, both by government and private sector, have given us fresh reasons for this hope. Another recent Financial Times article by Wilson and Bott actually describes the recent excitement in nuclear fusion experiments and startups. A Chinese tokamak, remember the tokamak is that chamber in which nuclear fusion happens. So one in China sustained a fusion reaction at 120 million degrees Celsius for a record 101 seconds, which is quite a lot given that most times these experiments are like last microseconds. Perhaps the most excitement was created by the National Ignition Facility in the US, created tremendous excitement by using 192 lasers to generate a fusion reaction that came closest so far to achieve net energy, where the energy produced was approximately 70% of the energy used. And this 70%, by the way, was much greater than earlier attempts. The next aim is to reach break-even, where the energy produced by fusion matches the energy used by it. Nuclear fusion startups are booming, burgeoning. The Fusion Industry Association estimates almost 35 of them, and they're growing rapidly. Bill Gates, big names, Bill Gates, Peter Thiel, and even Jeff Bezos are investing in them. About $5 billion of venture capital has been deployed. A recent startup called Commonwealth Fusion System raised a colossal $1.8 billion. Sam Altman, the guy who founded Y Combinator, put in 375 million in another one called Helium. Look, not all of them will succeed, but even if one of them does, it gives us clean, unlimited fuel to power our planet forever, much like the sun has been doing. Far, perhaps it's a little far, perhaps we are trying to attempt the impossible. But as one of the entrepreneurs, David Kingham, said, nobody has a better plan to deal with the climate crisis. And I tend to agree with him, and therefore believe that this is that one technology that could save our planet from the apocalyptic future that we ourselves have wrought. So this is the story of nuclear fusion and the hope of nuclear fusion. I hope this was useful to you. You enjoyed it. I do talk about technologies every week or so, and you can find these videos in my YouTube channel, Jaspreet Bindra or Tech Whisperer. And I would really urge you, if this interests you, to go and subscribe to that. Thank you very much.